This is episode 42 of our Chinmaya Algebra series, and for this video, we are given that a squared plus 3 is equal to 3a, and we're looking for the value of this quadratic polynomial, 8 to the fourth minus 2a cubed plus a squared plus 2. Now this is quite similar, in a way, to the previous two episodes, episodes 40 and 41. In fact, you can use the same methodology that we've done there, which is the substitution method or power reduction method. Basically, you would want to reduce the powers of 8 to the fourth and a cube into lower powers such as a and a squared. That's basically the same as the previous episodes, so you can do that. But for this episode, I'd like to show a method that is not quite popular and might come in handy, not just for these problems, but for other types of problems as well. This is the synthetic division for quadratic polynomial. I just like to do a quick recap on the synthetic division for a linear divisor. For example, let's say that we are trying to divide x cubed plus x squared plus 2x minus 1 by x minus 1. So what we would do here is we would solve for x that will make this expression 0. So that will be x minus 1 equals 0 or x is equal to 1. And then to use synthetic division, we'll write down the coefficients of x cubed, x squared, x, and x to the 0. And that would be 1, 1, 2, and negative 1. So it's the coefficient of this one, this one, this one, and this one. And then by standard practice, we do it this way. We put the 1 in this way. And then draw a bar here. For the first term, we drop it as it is. So that would be 1. The next step would be to multiply this result by our number here. So that would be 1 times 1, which is 1. And then we add these terms. We'll get 1 plus 1. Of course, that's 2. Then we repeat the procedure. That's again 2 times 1, which is 2. Oops, that's 2. We add them, we get 4. And then we multiply again 4 and 1. That would give us 4. And then add them again to get 3. Since this is x cubed, we're dividing by x minus 1. This has a power of 2. So this will be 1x squared. And then we do it in reducing powers, 2x plus 4. And then the last term would be our remainder. Therefore, the remainder when we divide this polynomial by x minus 1 is 3, with a quotient of x squared plus 2x plus 4. The method is quite similar for higher orders of divisors like a quadratic polynomial. So first we rewrite the divisor in terms of a squared, or sorry, in favor of a squared. So that would be a squared is equal to 3a minus 3. And then we'll rewrite the dividend as 8 to the fourth plus 0 a cubed, just to make it clear that there is no a cube here, minus 2a squared, or 2a, what am I saying? Actually, there is a cube here. What's missing is the a. Okay, so let's do another take. So we have here 8 to the fourth minus 2a cubed plus a squared plus 0a plus 2. So this is the missing term. And then we'll rewrite the coefficients in our synthetic division tabulation. That would be 1, negative 2, 1, 0, and 2. We can't forget this missing term here because the number of entries in our synthetic division table would determine the degree of the polynomial. So if we remove this one, we will only have 4 coefficients, which means that we would interpret it as a cubic polynomial. Whereas when we have 5 entries here, it will be a quartic polynomial. So for this one, since we have a quadratic divisor, we will write this as with the coefficients 3 and negative 3. So we'll write it here, negative 3 and 3. And then we will leave 2 spaces here and here. For the first step, we still drop the first term. That would be 1. And then we multiply this one by the coefficient of, or the first coefficient, which in this case is, oops, I wrote it incorrectly. This should be positive 3 and negative 3. The first coefficient here would be 3. So that would be 1 times 3, which is 3. We write it here. And then again, we add them. Positive 1. And then for the next column, we would be multiplying this by the second coefficient. That's 1 times negative 3. That would be negative 3 here. And then for the last row, we would be multiplying this one by this one. That would be positive 3. We add the coefficients again in this column. That would be positive 1. Basically, there would be a log between the first and second coefficients products. So this will be matching, this will be matching, and this will be matching. So we repeat the process. We multiply 1 by negative 3 to get negative 3 here. And then we multiply this one by positive 3 to get positive 3 here. Then we add them, we get 0. We repeat again. 1 times negative 3 should give you negative 3 here. And then 0 times positive 3 should give you 0. You add them, you'll get negative 1. Now this is a quartic polynomial divided by a quadratic polynomial, so the result should have a degree of 2. That's 4 minus 2. So the result here would be 1x squared plus 1x plus 1. Now we will have 2 terms here. The first one would be the coefficient of x. So we'll have here the remainder, that is 0x minus 1. We simplify this as just negative 1. So this will be a quotient of x squared plus x plus 1, and then a remainder of negative 1. How is this relevant to the given problem that we have? If we know this, then we can rewrite this expression here as, actually this should be a. This thing here should be a instead of x. But anyway, we will have here a squared plus a plus 1 times our divisor, that is a squared minus 3a plus 3. This is it. Plus the remainder, that is negative 1. However, we know that from this part, we know that it is equal to 0. Therefore, when we multiply this by 0, we simply get 0 on the first term. Then we add that to negative 1, we'll get the value that is negative 1. Therefore, the value that we're looking for here is negative 1. And that's our final answer. Actually, what I did for this video is quite longer than it should be. The shorter solution for this one perhaps would be by reducing the powers. But I wanted to just discuss this method because I think this is of importance as well, or could be of some use for certain or for other types of problems. Not just this type of problem, but like when dividing two polynomials. Actually, if you're very comfortable already with this method could yield you the result quite as fast as well. I just took the time because I had to explain the details uh, in this video. But if I have to do this, I think this is doable in like 20 or 30 seconds. Anyway, that would be all for this video. I hope you learned something from this. And if you haven't subscribed yet, I highly encourage you to do so. And thank you for watching. Please subscribe for more content and see you on the next one. Bye bye.